Problem 6-55. Use the ideas from problem 6-54 to help you solve the following equations. Letter A, log of 10 equals log of the quantity of 2x minus 3. So as we look at this, if you already did 6-54, that would make sense and would probably help you here. But if we're looking at the log of something, and remember, when we're talking about log, we're talking about base 10. It's not written in there, but it's like saying base 10. But if we took the log of something, and we said it was going to equal log, same base, so log base 10 of something else, okay, let's say we threw a 10 in here. So if we threw a 10 in here, then this would also have to equal 10, wouldn't it? But if we have an expression like 2x minus 3 in here instead, then we know that this expression, 2x minus 3, has to equal 10 in order for this to be true. Because if we're taking each of these here and they're equal to each other, we have the same base. That's a big part of this. We have the same base here. Then that means that the values here, or outputs here, are going to have to end up being the same. So let's do 10 equals 2x minus 3. And now all we have to do is just solve it. So 13 is going to equal 2 times some value we don't know. So we get 13 halves equals x, or I think that's the same thing as 6.5 where I come from. So x equals 6.5. If we were to take that and plug that back in here, 2 times 6.5 is 13, minus 3 is 10, and if I do the log of 10, it should equal the log of 10. Let's apply the same thing here to letter B. We have the log of 25, and we're saying that's going to equal the log of the quantity of 4x squared minus 5x minus 50. Well, if these are truly equal to each other, we are taking the log of each side here, but if they're truly equal to each other, that means that whatever we have inside of here, after we plug in the value of x, it's got to equal 25. So we need to figure out what can we plug in for x that would make this entire quantity equal to 25. So let's take that quantity and set it equal to 25, and then solve it. So 25 equals 4x squared minus 5x minus 50. Once again, remember, we can do this because we're taking the log of both sides, but it's log base 10. If we have the same base, that gives us the freedom to do this. Since it's quadratic, I need to set it equal to 0 here. So we should have 0 equals 4x squared minus 5x minus 75. And as we go through here, we'll ask ourselves, there's several ways to solve quadratics. First thing I'm going to check is, does it factor? I don't see a common factor between the terms here, so I'm going to go ahead and factor it. And it's been a while since I've done generic rectangles, so I'm going to go ahead and do that here, especially since I have a coefficient besides 1 here. So I'm going to go ahead and set up my generic rectangle. And then my diamond as well. Should make it a little bit easier for us than playing the guess and check game. Remember, first term goes down here, so I've got a 4x squared. Up here, I'm going to put my last term, which is negative 75. My middle term goes in the middle of the diamond in the bottom, so minus 5x. So our product of these two should be negative 300x squared. So I'm looking for factors of negative 300 that have a sum of negative 5. I think I got it already here. I think that would be what? Negative 20x and positive 15x. Yeah, really, I cheated. I've already worked this one out. So negative 20x there, 15x. Our greatest common factor between 4 and 20 is 4. Between x squared and x is x. So if this is 4x, that means that this dimension has to be x. And then 4x times what gives me negative 20x. That's going to have to be a minus 5. And on the other side here, x times what is 15x? Well, that's going to have to be 15. So this factors into the quantity of x minus 5 times the quantity of 4x plus 15. Still not done, we just got the factoring done there. Let's use our zero product property. We've got x minus 5 is going to equal 0, or 4x plus 15 is going to equal 0. So we get x equals 5. Over here we've got 4x equals negative 15. I've just subtracted 15 from each side, divided each side by 4, and I get x equals negative 15 fourths, which is the same thing as negative 3 and 3/4, or negative 3.75. So in this case, we're going to end up with two different answers. X can equal negative 3.75, or it can equal 5. So now let's go ahead here. Let's check this problem here real quick. And remember, you can check this one the same way you check any equation with your calculator. Let's look at the left side here. Let's create an equation for that. Let's say y equals the log of 25. And then let's create a second equation or function here for the other half of our equation, log of 4x squared minus 5x minus 50. Now let's go ahead and graph it. And remember, we're just going to look for the intersection points of our two graphs. We're looking for that x value, or that input value. So we'll see it comes in here. Our red one is our log of 25. And our blue one here is the log of the 4x squared minus 5x minus 50. Notice that none of them drop below the x-axis because we're not going to be able to come up with a negative output for these values here. So let's just go ahead and do our second trace. And let's go to number 5 here. So I'm going to move it over a little bit closer to the intersection here on the left. So enter. And I'm going to move my second. There it is. Sometimes you have to move it around to find it. Hit enter, enter, and I get that my intersection point is negative 3.75. I've seen that before. And then let's do it one more time with the other side here. Let's move it over here just so it's a little bit closer to our intersection point. Enter. And then move it over here. Enter, enter, intersection, x equals 5. So we've got both of those in there. So we have not only solved it, but we've checked it to make sure it was correct. Hopefully this helped you out. If you were struggling with this problem, this is 6-55. If you have questions, make sure you ask your teacher. Otherwise, thanks for watching and good luck.